Hi, I'm Lindsay from StatsMedic, and in this lesson today, we're going to continue learning about binomial distributions. So we've got two learning targets. Now, the first one we actually talked about yesterday as well, and that is to determine whether the conditions for a binomial setting are met. And then second, we're going to talk about calculating the mean and standard deviation for a binomial random variable, and then interpreting those as well. All right, so we've got a little bit of a surprise for you. Today, you are taking a pop quiz. Hope you're ready for it. The quiz is 5 multiple choice questions, so each question has options A through D. The bad news is, unfortunately, I'm not going to give you the questions. I just want you to guess the answer for each one. So I want you to quickly take a moment and on your Scantron up here or in your bubbling section, take a moment and guess what you think the answers are to the questions. Okay, hopefully you filled those in. So now I'm going to give you the correct answers. So I would like you to go through and correct your own quiz. The answer to number 1 is B. The answer to number 2 is D. Number 3 is D. 4 is A. And 5 is B. Okay, and then you can score yourself and see how you did. So how many did you get correct out of the 5? Okay, now obviously this pop quiz is just for fun, but what it's helping us to think about today is the probability of getting a certain number correct based on if you were just guessing. So what I'd like you to do right here is you are actually just going to work through questions 1, 2, and 3. So on number 1, you're just putting in the number you got correct on your quiz. And number 2, determining whether or not this is a binomial setting. And as mentioned, we talked about that in the last lesson. And then the third one, calculating the probability of getting exactly 2 out of the 5 questions correct. So take a moment. And work through that and then hit play. All right, so let's start with number 2. In the previous lesson, we talked about the way we determine if a setting is binomial is by checking bins. So the first part, B, is for binary, meaning the only 2 outcomes are success and failure. So in this case, you want to say what those would be, which would be getting the question right or getting the question wrong. I, independent, I would say this is independent. Each answer doesn't affect the next one. For N, we're giving the number of trials, which in this case is 5. And then S is for same probability. In this case, the probability of getting it correct would be 0.25 because it's 1 out of 4 chances. So yes, this is a binomial setting. Since it is a binomial setting, I can calculate the probability of getting exactly 2 answers correct. So this, again, is a recap from yesterday's lesson. I've got here 5 choose 2 times, and then I'm thinking about, okay, what's the probability that I get an answer correct? It's 0.25, and I need that to happen 2 times. If I get 2 correct, that means the other 3 had to be wrong. There's a 75% chance of getting an answer wrong, and I need 3 of those, so I get 0.264. So what I'd like you to do here is you're going to use that 0.264. Remember, that's the probability of getting exactly 2 correct, and I'm going to fill that in down here in my table. 264. Okay, so when we're thinking about this quiz, there are all these different possible number of answers that you get correct. So you could get 0 right, 1 right, all the way up through 5. What I'd like you to do is I want you to find the probability of each of those outcomes. Now I'm going to help you out with this first. I'm going to show you a shortcut that you could do in your calculator. So there is a function in your calculator, and it is called binom PDF. And what we enter in to our binomial PDF is we're going to enter in N, comma, P, comma, and then I'm going to put X in this case. So what that means for this one is I'm going to put in binom PDF for 5, comma, 0.25, comma 2, because I'm trying to find the probability of getting exactly 2. So let me show you where that is. So we can find binomial PDF under the distribution section. It's in the same menu where you would find your normal CDF. So I'm going to do second, and then the bars button, which gives us the distributions above. And if I scroll down, there we go, Binom PDF. And so again, we're setting in first N, or a number of trials, which is 5. P, which is 0.25. And then the X value, in this case, we're finding exactly 2. And then it enters it in like this. Now, if your calculator doesn't give you those prompts, it might just start you on this screen. You just type it in as I told you. So it's N, comma, P, comma, X. And then hit enter. And that is the same as the value that we found, 0.264 if you're rounding. So you can use that if you'd like to fill in the rest of this table. So again, I want you to find the probability of getting exactly each of those values correct. So 0 correct all the way through 5 correct. And now once you've done that, you've created a table. And then we've talked about before, how do you find a mean and standard deviation from that? So I'd like you to go through and then calculate a mean and standard deviation using what you've learned in previous lessons. And then in questions number 7 and 8, you're also just using the values from your table to answer those. So I'd actually like you to go through and complete the rest of the page. So pause the video, and then when you're done, hit play and we'll go through it. All right, so let's go through your answers. So on number 5, we've talked about in previous days that when you're trying to find the mean of a random variable, we take each value of X, multiply it by its probability, and then add them all up. So that's what I'm showing here. I've got just the first couple and then dot, 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 and get to the end, and I get 1.25. So I want to talk about that 1.25. So I was thinking about, well, I have 5 questions, and I have a 25% chance of getting a question right. Well, I'm noticing 1.25, isn't that just 25% of 5? And doesn't that make sense? Like if I'm just guessing on a multiple choice question, of course the average should be 25% of 5, because that's the chance that you get a question right. So what I'd like you to add into the margin here is I'm noticing, well, this mean, it's really just that probability times the number of questions. So for example, if I were doing a 10 question quiz, as a teacher, wouldn't I expect the average to be 2.5 correct, because 25% of the time the kids are going to be right? So what I'd like you to put over here is I'm going to say for a binomial distribution, that mean of X, we could find it the way we did. We could take every value of X, multiply it by its probability, add them all up. But there's also a shortcut here. And that is that instead we can do N times P. So you're taking, in this case, the number of questions times the probability of getting them correct. So that is a shortcut for finding the mean of a binomial distribution. Now you could do it just by hand if you wanted also. All right, let's talk about our interpretation then. So the average score we said is 1.25, or that's the mean of the distribution. So that means to me the average score on the quiz is 1.25 correct. Well, there's a couple of things I want to add in here. Now remember, when we're talking about probability, and this is based on a probability, we want to talk about how it's in the long run. It's over a long period of time. So what I'm going to add to the front of this is I'm going to write here, after many quizzes. So sneak that in wherever you have room. We're not talking about the average on just one student's quiz. We're talking about if we did this lots and lots of times with lots of students, the average should be 1.25 correct. Now, something else that you'd probably be wondering is 1.25 correct. Let's say you go home and tell your parents, oh, the quiz average was 1.25. What do they want to know? They want to know, well, out of how many questions? Are we talking out of 2 questions? In that case, that's not that bad. Are we talking out of 100 questions? Well, ooh, then that quiz went really bad. So what you need to include in these also is out of how many. So I have on here now, after many quizzes, the average score on the quiz is 1.25 correct out of 5 questions. So you do want to make sure with these that you are including N, so you're telling out of how many trials this was. All right, excellent. Number 6, you probably did this in your calculator using your frequency list. I got a standard deviation of 0.968. You could find that by hand if you wanted. And that is again telling me the number correct on the quiz typically varies by, and then I've got my number correct, 0.968 correct from the mean of 1.25. One thing, again, I do want to add though is out of how many. So you could put this here, you could say the number correct out of a like 5-question quiz, quiz of 5 questions. You could also put it at the end, like 1.25 correct out of 5. Anywhere is fine, just make sure you have that somewhere. Now, there is also a formula for standard deviation for binomial instead. So again, you can still just continue using your list functions in your calculator, or there's formulas we've learned before. But a shortcut for binomial is that the standard deviation of the binomial distribution is the square root of n times p times 1 minus p. And that'll be true anytime you are in a binomial setting. All right, great. So let's look at 7 and 8. So in number 7, we're asked the probability of at most 3. At most 3 means it can be at most 3, so 3 or below. So I've written here x is less than or equal to 3. And then I just went up to my table and I found all of those values, or these ones here, and I added them all up. And I got 0.985. And then the last question, number 8, probability of getting 3 or more. So the probability that x is greater than or equal to 3. Again, I just found the values from my table, added them all up, and got 0.104. Now, the inconvenient part of this is to answer both questions 7 and 8, you had to find all those individual probabilities, which took a long time. So again, there is a shortcut in your calculator that will do that for you. So we just looked at binomial PDF. Now what I'm going to look at is binomial CDF. And I'm going to start on number 7 by writing out what command we're using. So it's binomial CDF. And now again, we're starting with n, then our probability, and then our x. So in my calculator, what I'm going to be writing or typing in is going to be binom CDF 5, 0.25, 3. And in the margin over here, I want to write that's the probability of x being less than or equal to 3. Now, how that's different from our binom PDF up above is this was the probability of getting exactly 2 correct. So what I'd like you to add in next to this one is this is the probability of x equal to 2. So we use binomial PDF when we want the probability of exactly a certain number correct. Binomial CDF is you want that value or less for successes. I remember that one because I think of CDF as cumulative, so it's everything from that point and before. Okay, so let me show you where that is on your calculator. So I'm going to go back into distributions again, and it's actually right below binom PDF. There we go, binomial CDF. So I'm going to click on that. 5 trials, 0.25 is my probability, and then my x value that I'm using is 3. And I get 0.984, and that's a little bit different due to rounding errors, but basically the same thing we had gotten above. Okay, now what about this last one then? Well, for number 8, we have to be a little bit more careful if we do want to use binomial CDF for this, because remember the binomial CDF is less than or equal to, and this one I want greater than or equal to. So what I like to do is I need to think about, okay, what am I going to enter into my calculator? Binomial CDF only gives me the left side. So what I think about generally is I'll kind of write to the side, do this over here. Okay, what could I get? I could get 0 right, 1 right, 2 right, 3 right, 4 right, or 5 right. Okay, what is this question asking me for? They're asking me for 3 and above. So what am I going to ask my calculator for? I'm going to ask my calculator for 2 and below. And then that 2 and below, I'm going to take away from 1. So I'm going to put this down here in green. So remember, it goes with that green arrow. So this one's going to be binom CDF of, again, 5.25, comma. Now remember, I'm asking for 2 and below. So I do that in my calculator to get a value, and I get from that 0.896. Now that is the left side. I want the right side, so I can do 1 minus. So I'm going to sneak 1 minus into all of these, and then my final answer is 1.04, same as I got above. So these calculator functions sometimes are really helpful, especially if you have to find a lot of different probabilities. Sometimes it might just be easier to do them by hand. So sort of use whatever process seems best to you. All right, let's look at the important ideas. Okay, so our first learning target was about determining whether or not something was a binomial distribution. And actually, the reason we're doing that is because we want to get at an idea about describing binomial distributions. So if you're asked to describe a binomial distribution, first you need to decide, is it binomial? So step one would be we check bins. If that has happened, then we can use everything we know about binomial. Okay, so if you are asked to then describe, well, when you're describing, that means you need to do shape, center, and variability. So if you're asked to describe the shape, with this, I would recommend just making a histogram. You could make a table like we did on the front page and then turn that into a histogram to decide what the shape looks like. The center, you're going to talk about the mean. And then the variability, you're going to talk about the standard deviation. And now we have rules for that mean and standard deviation. So we'll add that. That was our second learning target. So the mean, let's add in this. So I'm going to say again, so for binomial distributions, the mean is mu, we usually use x there, is equal to n times p. And my interpretation of that, I'm going to say, is after many, many trials, the average number of successes, and you should put that in context, is blank out of n. So again, make sure, here I'm going to put mu of x, make sure on this that you are saying it's out of how many trials. Okay, so that is for mean. For the standard deviation, our formula is the square root of n times p times 1 minus p. And my interpretation is the number of successes, and again in context, typically varies by blank from the mean of, and what I would do here is again say like out of how many. That way you know you've covered your bases on that one, so from the mean. So I'd like you to try to check your understanding problem, so work through those questions, and then when you're done, let's go over the answers. Okay, so I've got here for part A, the first thing is we are being asked to describe, is this a binomial distribution? So I've just talked through all of bins, described what success and failure are. Because we're putting the paper back every time, it is going to be independent. We are doing this for 10 trials, and the probability of winning is 0.25 because there are 25 out of the 100 slips. So this is a binomial setting. In part B, we're asked to make a histogram using the probability distribution of y. It says to do that using technology. There are lots of different ways you could. You could go to Staplet. There's a really nice binomial distribution menu on there, which would allow you to make a histogram. You could also do it in your calculator by making lists. So that's kind of up to you. It'd be pretty rare that you'd be asked to make a histogram with this many outcomes. So it's possible you might make it with fewer on a test or on a quiz, but otherwise, generally, it would be given to you or it'd be a small number of trials. Either way, from looking at this one, I can see that it is slightly skewed to the right. And then in C, calculate and interpret the mean of y. So because it's a binomial distribution, I can use my new formula, n times p. And I get 2.5, which means that after many, many sets of 10 drawings, the average number of crinkled papers drawn is 2.5. So you can say it that way. You could also say like after many, many drawings, the average number of crinkled papers is 2.5 out of 10. As long as you have that out of 10 in there somewhere, you should be good. And then D, our standard deviation is 1.369, which means the number of crinkled papers selected in a set of 10 typically varies by 1.369 from the mean of 2.5 papers.